Hello. Good morning. Good morning. Good morning, Chef. Welcome. Hello. Good morning. Uchu, welcome, Brandon. Hello. Morning, CS202 student. Good morning, Cade. Good morning, Kane. Welcome. Good morning, Waffle. Good morning, Synthos. Welcome. Good to see you guys. Good morning, Hamma. Hello, Turbo. Chef asks, will the plus operator be normal if we use it on something like an int and an int or a float and a float? And the answer to that is yes. You can imagine that somewhere hidden in C++ is you have an int operator plus int somewhere. You probably have quite a few of them actually. There's probably an int plus a float, which returns a float. There's probably a float that takes these things. And the thing to remember about that, Chef, is if you take a step back all the way to one of the first days in class when we talked about function overloading, is how do we know which function to call? And it's based off of not only the name, but it's based off the parameter list. So what is the thing that's going on here? Well, if I didn't have these things, I'll just take out one of them. You'll notice that the compiler, or C++, doesn't know what that is. This operator doesn't exist for these parameters. So we can define it that way. Does that answer your question? We may even be able to overload the original one, but I don't see any point to doing that. Giovanni, welcome. Good morning. All right, it's 11:31, so let's get started. We're praying today for some good connection. All right, good connection today. If we have a bad connection, I'll have to make some videos, but I think the work outside my house is done. So hopefully we're going to have a good day here, and hopefully we're going to finish up operator overloading. So let's just say a few things. Assignment, gosh, I'm lost. Assignment 5 was due last night, right? If you're still working on it, you're welcome to email it to me. In terms of lines of code, that assignment wasn't very long, right? But there was still some kind of high-level thoughts going on in there. Of course, we did run into a hiccup with the invalid freeze. And if you saw the Discord, I did figure that out. But I did kind of learn something from that. Was the assignment PDF, I think, was pretty straightforward, but we still had some confusion. So for assignment 6, we're going back to Mr. P assignments. That's just how I like it. That's my favorite kind of way, because I can make sure that everything I've taught is in that assignment, and everything in the assignment is what I've taught. So, yeah, I mean, we ran into something with, say, we've done assignment 1, assignment 2, we've done assignment 5. Of course, assignment 1 was a bit of a nightmare. Assignment 2 wasn't so bad, but it still had some things in there that I didn't teach. This assignment 5 had some things that I caught that I was like, this is not fair. So we're going to go back to my assignments. So thanks for hanging in there. I'm glad that you're happy about it. Cade, thanks for that. I like my assignments too. Yeah, so I'm sorry about that. But in terms of assignment 2 and assignment 5, I would say that they were fair, all right? I mean, obviously there was some confusion, but I helped you out as much as I could, and I even gave you some code. So we're going to leave it at that. They were fair, and you could complete them. But like I said, we're moving back to Mr. P assignments. That being said, assignment 6 will probably go up today. I'm just finishing it up. It's going to be pretty simple, but I would recommend getting started on it early. I will make a video for that. You guys are so nice. Thank you. You guys are too nice. All right, so with all that being said and out of the way, we're going to move on to today's subject. Now, obviously, last class we ran into some connection issues, so we're going to be kind of speedy today. We're going to try to learn everything we need to know about operator overloading. Truth is, it's not a lot of material. It's just some things to memorize. So let's just briefly review what we did last class when we had a good connection. The first thing we talked about were friend functions, right? Now we're going to learn today why we need them. But simply put, it's any function that is defined to be a friend of a class will have access to that class or that object's private variables. All right, and I gave you an example of that in code, right, with that update person function. That should be on Web Campus. If it's not, I'll get it up there. Okay, so I've given you the example here. Notice that the function is defined globally, or more specifically, it's defined outside of the class. And if we want it to be a friend, we have to type that it's a friend and include its prototype in the class itself. So this, in some sense, it looks a little bit like a member of that class, but it's not. Rather, it's just a friend of that class. Okay? So we talked about those, and then we got to the basics of operator overloading, right? So we have a left-hand side and a right-hand side, almost always. Depends on the operator, right? Sometimes operators take 3. Sometimes operators take 3 operands. Sometimes they take 1 operand, unary, binary, trinary, things like this. So There might not always be something that's like specifically a left hand and a right side, but for this class, we need to know what they stand for. All right, so we have the left-hand side and the right-hand side. We also described what an operator was, which is some symbol that represents some function, right? Represents some function. And here are some symbols, right? We know these ones. Now, what's an operand? Well, it's an argument that is supplied to the operator. You guys should know what this is. If we were to look at our code from last class, the operator is this symbol, right? It's the plus. The operands are what is supplied to the operator. So here we have this S and this X. Those are operands. Additionally, if you look at this kind of as a operator with operands, the operands are Cout, and if I put them in parentheses, S plus X, that's also an operand. So we've got Cout and S plus X as an operand, and then there's the operator. And then if you want to look at it in even the bigger picture, we've got this, where we have an operator here. And what are the operands? Well, this is the operand for that operator, and this is also an operand for that operator. All right, so Chef kind of mentioned that last class. We were kind of looking at, how does this work? It's a little interesting. Of course, we'll talk about it today. But as you can see, everything can kind of be broken down and then simplified to keep things as, say, binary operators, right? A plus B plus C. Yeah, I went over all of that. If you want to go back and look at it, you can. And we did some examples, right? So if you want to look at that stuff, you can. And of course, we talked about, say, some operators are binary and some are unary, depending on what we supply to them, right? In this case, we supply 2 operands, therefore we're doing multiplication. If we only supply 1 operand, we're doing a unary operation, therefore it's a dereference. Now we can only, I'm going to kind of skip ahead here, we can only overload operators that are in C++, meaning we cannot define our own operators. So if you want the list, here's where you go. Okay, if you want the list, here's where you go. Now, of course, we've done operator overloading before. You haven't typed it explicitly, but you've used it. And for string in particular, you can do concatenation. That's S plus B. You can also do the brackets, right? That's S bracket, say, 4. So you've used operator overloads before. They exist. So now we're going to learn to do it for our own classes. And not even our own classes, we're also going to learn to do it globally too. That's kind of what I did. So I already mentioned that. And then we need to talk about what operators cannot be overloaded. Just remember this list. You can save it somewhere. You can even Google it. I think C++.com lists these as operators that cannot be overloaded. So there's the list of them. There's 5 of them. Now, what are the requirements for an operator? Well, now that I'm looking back on this, usually we're going to use a class or a struct, but it's actually not required, always. And it's not required because I showed you here that in this program, we actually didn't define our own class here. You notice that we are using one, but, if we wanted to talk about something like, I don't know, an int plus a bool, we may wish to do an operator overload for that. So in some sense, you don't really even need your own class. You just need an operator and whatever parameters you are working with. Now remember that to note that the order of the operands matter. All right, always remember, things go before others. Like I showed you here in this example. I need to have both of these if I want to be able to interchange them. If I don't have one of them, then say, in this case, with the X and the string, where the X comes before the string, we're not going to be able to do this one. All right, order of operands always matters. And then finally, we talked about, or we briefly mentioned, that operator overloads are like functions, which means that they can be global, or they can be members of a class. So we're going to go ahead and kick off with this today. Now, Chef did have some questions at the beginning of class. I did kind of answer those. Is there anything about this example that we don't understand before we continue on? This is kind of where we got hung up last class. If you have any questions about what's going on here, please let me know. All right, we basically just did two operator overloads, providing the parameters that we want. For example, a string and an integer. All right, if we want to use this somewhere in our program, we may wish to do that. So let me know on that. Synthos asks, how come we were able to switch the operand, the parameters in the function like this? Because it matters in the sense of how it's called. So yeah, this is very important to consider, is the left-hand side and the right-hand side. Here you need to look at what's on the left-hand side of this operator and what's on the right-hand side of this operator. And then if you were to, say, convert it into some sort of function, what the operator here is it's a plus. And what goes in for the left-hand side? Well, that's the string. What goes in for the right-hand side, that's the int. And so in order to call an operator like this, just like any function overload, the operands, the parameters, have to match. Meaning it has to go string int. Well, where is that one? It's right here. If you look at this one, you do the same thing. What is the operator? Well, it's a plus. And what is the order of it? Well, the int is on the left-hand side here. So we put in an int. And then what's on the right-hand side? It's the string. Now, is there anything that matches those parameters? Well, currently no. And that's why it's mad at us. So if we say, put this code in here that takes those orders, then we're allowed to. So we are able to switch the operand, the order of operands in the function. And the reason for that is because the order of them matters, all right? And the reason we're allowed to switch them is because we defined two operator overloads, each to handle one of those cases. Chef asks, is the first param always the left-hand side and the second param always the right-hand side? That is correct. Let's go ahead and add these in the notes. Those are good questions. So when we read an expression, it is always from the left-hand side to the right-hand side. So when we're reading an expression, it's always from the left-hand side to the right-hand side. So if we say 3 plus 4, 3 is the left-hand side, 4 is the right-hand side, and that means our operator looks like this. Operator plus, where the 3 goes in left and the 4 goes in on the right. Pig says, does that little squiggly under the sign indicate that it isn't overloaded? Yes, that's exactly what it is. And I'll show you the error that's generated by this, actually. I know you've seen the error before, actually. So, do you see this? If I highlight it, it says no operator matches these operands. And it's even telling you what the order of them is. It says the types are int and string. And so if I save that and I go to Bobby and I compile it, I'll tell you the error that you get, you have seen it before. And it is not a very descriptive error. It is not a very descriptive error. G++. Sorry. All right, so look at this. What the heck am I looking at? This is nasty, right? You have seen this before, I assure you. You know why you've seen this before? I'll tell you. Say you did this. Struct. Let me kind of bring back some nightmares here. Unigram, right? All right, you've declared, say, a class, and it has a string, I don't know, str, and it has an int frequency, right? And then I ask you to print this, right? So if I'm down here and I say unigram, mygram, and I say cout mygram, this is where you see the error. Why? Because there's no operator that matches. This is an O stream. That's what we call this. There's no operator that matches an O stream. You can see it there. And a unigram. Why? Because you didn't overload that operator for this type. So what are you faced with? This nasty bleh. And if you scroll up through it, you'll find it eventually. Here it is. Look. There it is. No operator matches these operands. So yeah, obviously that error is disgusting, but you can kind of find what it's telling you if you scroll through all of that. So I hope that answers that question. Then our next question is, can you make a custom operator such that it is made of 2 or more symbols? Like plus. So the answer is no, you cannot. The compiler only knows a set of operators. It only knows a set of operators, and that set is what I've mentioned, or what I've linked to you. I'm clicking on the wrong notes. That I've linked to you somewhere in here. This is the set of operators you're allowed to use. And what you're saying there, kind of, is if you think about it like a ternary. I'm not sure about that one. Let's talk about not equals instead. If you think about it, not equals is like that, because not is it's a Boolean operator, and then equal is the assignment operator, and then you've combined them together to make not equals. That is a C++ defined operator, so you have to use that one. You can't combine your own. And then Cinto says functions are called by the left-hand side and the right-hand side, and that correlates to the function. Yes. And reading from left to right is the what's going to kind of segue here into this next segment. So I'm glad we talked about that. Thank you for those questions. Those were nice. Those were very nice. So now we're gonna move into some things here. All right. So a global operator. This is any operator that is overloaded globally, okay? So, in some sense, a class is not required for this. All right? Class is not required for this. Now, there are some operators that have to be overloaded globally, meaning they cannot be members of the class. All right, and I'm going to give you the example of this. We're just kind of putting the notes in here for now, and then I'll kind of show you what this looks like. But there are only 2 operators that cannot be members of a class. There's only 2 operators, and those operators are always have to be global. That is the I always get them mixed up. The insertion operator. Now, is anyone like me and think that the insertion extraction is like backwards? And then the next one is the extraction operator. Does anyone think that it would be switched? Yeah, right. For years I was like, this confuses me. Now, yeah. So what you have to think about here is you have to think about it in terms of the stream. So you have a stream on this side, and you have, I don't know, an int on this side. You have to think about it from not the point of view of your variable, but the point of view of the stream. So in this case, we are extracting something from the stream. We're extracting something from the stream and putting it into an integer. Similarly, if we are going to do this, we are inserting something into the stream. So when I ask you questions like that on the test, when I say insertion extraction, think about it from the point of view of the stream. Are we inserting to the stream, or are we extracting from it? So these, terrible. Terrible. Okay. It's 11:50, guys. Of course we have this hiccup. I don't know why it does that. But we're back now. And that's going to be our only hiccup for today. All right, we're going to have, that's our only hiccup for today. So let's continue on here. Now, there's a reason that these two operators are always, that they always have to be global. And this is, I'm going to ask you this question on the test. Why do they have to be global? The stream is always on the left-hand side of the expression. All right? So help me out here and make sure that what I'm saying makes sense. And that, let's say I'm overloading this for my class. All right, I'm overloading for my class A. I'm overloading this for my class A. And so somewhere down here, I'm going to say cout A. You know, if I have an object, say A, my obj. Actually, let's go ahead and get started on the code. That will make it better. You notice here I've got some mini matrix stuff going on here. Could you give a quick, what is a stream for dummies? A stream is something related to I/O, input or output. So streams are, say, your terminal. You're like you're inputting things from the stream or the terminal, or you're outputting things to the stream or the terminal. Similarly, you've done files before, right? File streams. So you can input things to the file, or you can output things to the file, or input things from the file. For those of you that know what string streams are, you can input things into the string stream. You can output things from the string stream. Is that a quick, what is a stream for a dummy? It's something related to input, output. Something that you can insert things to. It's like a stream. It's like a long string. And you can take things from it and you can put things into it. Kind of like an array, I guess. So when we're talking about this thing here, let's do a mini matrix. Now guess what? Your assignment coming up is to do with matrices. All right, this assignment, this code I'm doing for you should be able to help you. All right, but it won't help you the best, okay? So it's a mini matrix, it's not a whole matrix. So you can reference this code, but it won't be good enough to complete the assignment. You can't just copy paste it in there, all right? But you can reference this if you'd like. So it should help you, but not enough to just, you know, copy paste your way to victory. So remember that and reference this code if you need. So when I'm talking about, say, the stream always being on the left-hand side, I'm going to say something like cout here. Now the thing to note is the stream here is on the left-hand side, and it's always this way. There's never really a case. There is never a case, unless you are going to break C++, that you're going to have your object on the left-hand side. In the case, for our purpose of overloading this operator, the stream is always on the left-hand side. And so what does that mean? What do I mean by that? Well, think about it like this. If I were to overload this operator for this class, here's what it looks like. And I'm going to put this in the notes. You're just going to have to always remember it. This is what it looks like. You're going to have an O stream. All right, that's the out stream. O for out. And you're always going to return by reference. And I'll explain why we do that. And then you have the operator. What's that operator? Well, it is the insertion operator. And what parameters does it take? Well, from the point of view of what this looks like down here, it looks like it takes, say, some O stream. And it looks like it takes some mini matrix. Okay. Now look at it from this point of view, in that this is a member of the class. And if something is a member of the class, it indicates that it could be invoked from the class. All right, you could use the dot operator potentially. You might be able to say something like dot operator, and then pass in, say, cout, and then say your mini matrix. Now at this point, I'm probably confusing you. So we're going to kind of take a break from this. And I'm going to show you some other operators so that we can come back to this. Just notice here that this is kind of redundant, that we're going to be calling this we're going to be calling this insertion operator from an object, and then we're going to pass in the object. Doesn't really make sense to do that. So we're going to come back to this, just kind of remember what we're doing here, and it should all make sense very shortly. So remember that the reason that they are always global is that the stream is always on the left-hand side. And this will make some sense once we get to the class operators. So, similarly, this is any operator that can be a member of the class. All right, this is some operator that can be a member of the class. So Cade asked a good question there. Why are we using an O stream? Well, here's something you need to note. You've never used these before. If you type, if you do like a cout type of cout, that's an O stream. I don't even know if that works. Type ID maybe. There we go. If you do that, you're going to get an O stream here. It doesn't really like that, but that's an O stream. Now, we're not talking about files, okay? A file is different. What is the file output stream? Can anyone name that one for me, please? What's the one with the file? You guys should know that one. What's an output file stream? Excuse me. Yeah, OF stream, right? Yeah. So an O stream and an OF stream, right? An O stream and an OF stream are different, Cade. An O stream is a cout, I guess. Similarly, there's something called an I stream, and there's something called an IF stream. If we're talking about I stream, this is like cin. If we're talking about this, this is like in file or something. Make sense? So if you think about it, this is kind of like input stream. This is like input file stream. So there's no F in there. Clicking on the wrong one. All right, it's any operator that can be a member of the class, okay? Now, there are 3 operators that have to be members of a class. All right, what are those operators? Well, you've got a bracket, you've got the assignment operator, I didn't mean to put that there, and then you've got the parentheses. All right, parentheses are considered operators. All right. Now, look up here. Obviously, you guys are probably a little lost right now because of the order I'm going in, and that's fine. But I want you to use some critical thinking skills here. If these operators have to always be global because the stream is always on the left-hand side of the expression, or more specifically, the object is always on the right-hand side of the expression, right? Let's look at it in our little code example here. The object, ignore this one, the object is always on the right-hand side of this expression, all right? The object is always on the right-hand side of this expression. Why do you think these might have to always be members of the class? And just think back to these ones up here. Think about it. Why would these have to be members of the class? And we'll come back to that. Because the object is always on the left-hand side of the expression. That's 100% correct. And this one even makes a little bit more sense than the other ones. So let's come up here. Now, this one can't be a member of the class, so let's forget it. But let's talk about, say, the brackets. Well, what are the brackets going to return? Let's say we're doing an int matrix here. This is a mini matrix, so it'll be a 2 by 2. All right, we're going to have a little int matrix here, 2 by 2. And so this is going to be the member of the class. What does it return? Well, let's say we're going to return a row from this matrix. We're going to return, I guess, a column. It depends if we do XY or YX, right? We got super confused on that in the assignment as well. But what it's going to return is probably an int pointer operator. And it's going to take some index. That's kind of what it looks like there. That's kind of what it looks like. And so when I'm down here, am I going to do bracket 3, or am I going to do bracket 3 That's the question. Am I going to do equals or am I going to do equals or something like that? So I'm being a little confusing, but this doesn't make much sense, right? Additionally, this doesn't make much sense either. The only time that they do make sense is when the object is on the left-hand side. Notice here it is. is on the left-hand side. is on the left-hand side. Similarly, is on the left-hand side. Okay? So that's just the reason. That's a test question right there. This one's even a little more important than the one up above. There are 3 operators that always have to be members of the class, and it's these ones. The object is always on the left-hand side of the expression. Now, guess what? Any other operator can either be global or a class member. Things to consider. If it is a class member, you have access to an object through, what is this? This. And I'll talk about that. If it is not a class member, you must supply all of the operands. So what do I mean by this? Well, let's do some matrix stuff here. So we're going to come back to this O-stream crap in a moment. Sorry, it's not crap. Forget that I said that. Forget that I said that. It's not crap. And let's pretend that we're going to do some basic operators here, okay? Let's pretend we're going to do some basic operators. Let's do this one. Let's say we're going to do something where we can take a matrix plus a matrix. All right? So we actually have 2 options. This is operator plus. Operator plus. Now, I'm going to ask you guys, let's see if we're kind of in tune with this. If this is a member of the class, this is how it's called, by the way. If this is a member of the class, how many parameters am I going to pass it? We're going to pretend that this returns a matrix, okay? A matrix plus a matrix equals another matrix. So that's what it's going to return. Now, if this is a member of the class, how many parameters should we supply to it? All right, so Chef is correct. Chef is correct, but I don't blame you guys. I don't blame you guys on this one. Why is it only 1? This is actually the right-hand side matrix that we're supplying to this. This is the right-hand side matrix. Why is it only 1? Well, if you want to think about it, in this, let's say you've got 2 objects, mm1 plus mm2. This is similar to saying mm1 dot operator plus mm2. So Chef already answered that one for me. Where is your left-hand side? It's this. This is your left-hand side right here. And the right-hand side is obviously the right-hand side. Okay? It's obviously the right-hand side. So does that make sense? Now let's go ahead and, kind of figure this out. Let's kind of go ahead and figure this out. Any matrix plus a matrix is, I don't know, if you've got like 1, 1, 1, 1. Let's say if you add 1, 1 plus 1, 1. I don't want to spend too much typing these out, so let's just do it this way. This is terrible comments here. If you take 1, 1 plus this one, you're going to come up with a matrix that's 2, 2, 2, 2. Does that make sense? Basically, you're going to take the 0, 0 element plus the 0, 0 element, the 0, 1 element plus the 0, 1 element, the 1, 0 element plus the 1, 0 element, and the 1, 1 element plus the 1, 1 element. Now, Pig asked, did we review matrix at any point? Truth is, that's kind of another class. With your upcoming assignment, all of the stuff that I make you do is straightforward, like this. But I am going to offer extra credit on the assignment where I'll make you do, I won't make you, but I will offer you extra points to do matrix multiplication and a matrix transpose. So it's not required by any means, but I will give you extra credit for those two operators. And if you want to do that, you're going to need to probably watch some YouTube videos, unless you took a class like linear algebra or calculus, or I don't remember, right? But the hard ones that you need maybe another class for, those are extra credit. All of the easy stuff is easy. So we're doing this plus here. We're going to take the left-hand side plus the right-hand side. So we're going to take 1, 1, 1, 1 plus 1, 1, 1, 1, and we get 2, 2, 2, 2. I don't think there's any problems with that. So what we're going to need is, say, a new matrix, right? A new mini matrix. We'll call it the return matrix. Okay. That's our new mini matrix. That's going to be our return matrix. Now, notice it's part of the class here. And we're dealing with this object here. So pretty much we can just say that the R matrix 0, 0 is equal to, well, the left-hand side, right? That's going to be this dot matrix 0, 0. Whoops. Sorry, guys. I'm trying to do this entirely from the keyboard. It's going to be equal to that one plus, not this matrix, but the right-hand side matrix. Does that make sense? Now, it's a little bit mad at me here. That's fine, because I didn't access the matrix inside of it. But I can just kind of do this real quickly, right? I can do all of them. In your assignment, you're going to want to use for loops. All right? In your assignment, you're going to want to use for loops. Let's say we add them all together, and then we return the R matrix. Wow. Isn't that amazing? Are there any questions on that? Hopefully it makes sense, right? We're going to take mm1 plus mm2. That's like calling it from the object, right? Why? Because the object is on the left-hand side, right? Notice mm1 is on the left-hand side. So it's like we call it like mm1 dot operator mm2. So we've got this, which is the left-hand side, and we've got the right-hand side. Yeah, you are right. You are right. Thank you. Obviously, like I said, you're going to want to use for loops for this, right? Definitely going to want to use for loops when it comes to your assignment. Don't do this. Don't do this. It won't work. All right. So now let's do an example here of a global operator. All right. We actually have the option to do this. We have the option to do this. So let's do minus, right? Minus is just the opposite of it. All right. Minus is just the opposite of it. So let's say we're doing it globally. We're going to have a mini matrix operator minus. Now this one's global. So I ask you again, how many parameters will we supply to this one? This one is global, okay? This one is global. How many operators or how many operands, parameters, should we supply to this one if it's global? Two. Yeah, we're going to need 2 for this one. So I'm glad that we're getting that. All right, this one's global, so we're going to need 2. This one is the left-hand side, and you've got your mini matrix, probably your right-hand side here. Make sense? Yep, so that's the thing. That's exactly what I was talking about here, Cade. Right here. Things to consider. If it is a class member, you have access to an object through this. If it is not a class member, you must supply all of your operands. All right? So with these operators, you have some choices, right? Both plus and minus can be both, right? They can be global or they can be members of the class. You just have to keep in mind, if it's a member, you have this, right? So you only need to supply 1 parameter. In this case, we're going to need 2. Now let's see if you guys have been paying attention here. Let's see if you guys have been paying attention here. Let's say I'm going to basically do the same thing. All right, I'm actually just going to copy this. A lot of your code in the assignment will be copy pastable to some extent with some minor editing. Right, this is going to be minus, 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 right? Wow, that was hard. Okay, and then instead of this, we're going to do left-hand side. Let's see if I can do my amazing yes. My amazing... Oh, watch. I've messed it up, guys. I've messed it up. Left-hand side, left-hand side. Okay. No! I hate this. Go away. Okay. All right. So that's that, right? In this case, we don't have access to this, so we're going to supply it. Right? Down here, if we do mm1 plus mm2, we've got that. You want to know how I did that? When you're here, if you hold Alt on your keyboard, you can highlight multiple things, and it makes like multiple cursors. Yeah. Turtle's right. It's an Alt click. And this will be mm2, mm1 minus mm2. Something like that. Now we have an issue here. Okay, now we have an issue here, guys. So let's pay attention. What is the issue and how do I fix it? Our issue is that these are private members, right? This is a global function. We don't have access to these private members. That's our issue. How do we fix it? I taught you guys how to fix it. How do I fix it? This is a global operator. It does not have access to these private members. Chef says friend or helper function. When it comes to operators, we're going to do friend functions. Yes, you're right. So all I have to do is grab this. I can say, hey, please make this a friend. And what do you know? We've got some operators here. Easy enough, right? Easy enough? Easy enough. So I've given you an example of the global a global versus a class member. Okay, so remember this, that the operators that can go both ways. I've given you that example here. These are operators that can go both ways, and you're going to need to consider that. Now we're going to talk about, at least we have to get in for class today. We need to do the O stream and the I stream. We also need to do something like the bracket and the assignment operator overload. Okay, so I'm going to make this a little bit more difficult for us. You're going to be mad at me, but please don't. Because this is what your assignment looks like, so I might as well help you out with this one. Okay. So it's a mini matrix. In this case, it's only going to be 2 by 2. In your assignment, the matrix will be any size, okay? any width, any height. So you're gonna need to know how to allocate this stuff, right? This time we're doing a double pointer, which means it's a 2D array of objects in this case. So let's make our constructor real quick. This one's really easy. For int I equals 0, I is less than, I like to do the width first, not the height. I++. We're going to say mat is equal to new mini int star. Hold on, I messed up, guys. I'm getting ahead of myself here. I need to allocate the width first. And then I can say this is equal to the height. And then I can do another for loop. Yeah. So for this one, it will be XY. That's the way I think it should be, personally. If you saw in the assignment, the instructor who made that one included like an extra member function called like set value in matrix, and it swaps them. And he said, I've included this because having YX is kind of annoying. So yeah, for this assignment, I'm going to switch you back here. I'm going to switch you back. Yeah, you guys are right. My head gets ahead of me sometimes. Obviously, my head gets ahead of me sometimes. You guys are right. You guys are right. But I always get there. I assure you. I always get there. Except when I type O instead of 0. Okay? So, here you have it. Here you have it, folks. Here you have it. That's our constructor. Are you happy with it? We do the width, and then for each column, I guess, we do the height. And then for each of the height, we initialize it to 0. Similarly, how do we do the destructor? Well, I always like to copy paste this. Watch how I do this. Watch how I do this. I copy paste it. I say I have to do this backwards. So this goes down here. This one goes down here. Okay. And then I think for a second, am I deleting any pointers here? No, I'm not. So goodbye. And then I say I need to deallocate this. So I go delete. And I need to deallocate this one. So I go delete. In the assignment 5, we set it to null because it was a 2D array of pointers. But in this assignment, it's going to be a 2D array of objects, yes. You're not going to have to do the pointers in the next assignment. We're doing 2D array of objects in this one. So we're doing a double pointer here, not a triple pointer. Okay. Double pointer here. And we're setting it to 0 because that is the object, yes. All right, that's our destructor. So guess what? We're going to take a step back here. Guys, this is a class. This class contains a pointer. What does that mean? What does that mean? If this class contains a pointer, is there something we have to think about? Is there something we have to think about? What do we have to think about? Yes! The rule of 3. The rule of 3. So what else do we need? Well, that's number 1, right? This is rule 1 of 3. This is 1. You see, it's almost like what I was teaching you meant something. I'm not sure though. Rule 3, number 2. Now you're going to learn about a cool trick today. You ready to learn a cool trick? We're going to need the copy constructor. For this one, that copy constructor looks like mini matrix. What does it take? It takes a constant mini matrix by reference copy. Okay. You want to learn a cool trick? Well, before we do that, let's do the other one. Rule of 3, number 3. Crazy. Crazy how that happens. We're going to need an operator overload for the assignment, right? So I said we were going to do this. Here we are now, folks. We're doing the assignment operator, right? So what do these do? Well, makes a copy of the right-hand side, makes a deep copy of the right-hand side. Okay? Makes a deep copy of the right-hand side. That's what it does. Both of them do that, right? But we talked about, in the case, this one is a brand new object. You want to say left-hand side, I guess, is a brand new object. And here, the left-hand side is alive. Right? We talked about this. So if I'm coming down here, and I say something like mini matrix mm3, and I supply, say, mm1 to it, mm3 is a brand new matrix. But down here, if I say mm3 is equal to this, mm3 is already alive. Okay, so there's the difference. Now recall, this has to be a member, right? Let's go look in the notes. Let's put on our reading glasses here, and we'll find that, boom, there are 3 operators that have to be a member of the class. What do you know? The assignment operator is there. Okay? So here it is. It's a member of the class. Now it's time for a cool trick. Time for a cool trick. These both kind of do the same thing. These kind of both do the same thing, except for that difference. So let's say, I don't know. This matrix equals null pointer. And then I'll say this equals copy. Can anyone tell me what this does? Can anyone tell me what this does? Specifically, what does it do? Like, obviously, it's going to override something, but what happens? Something called? If so, what is it? What happens here? This is a fun trick. In fact, at this point, we're done. Done, smiley face. Well, I'll tell you. Right. Correct. Well, so Chef says, would it do just the first element of whatever is stored in the copy? Well, think about it this way. This is the matrix, right? This is the matrix where it's stored, but I'm talking about mini matrix, right? I'm talking about an object. This here is an object of mini matrix. This is not the mat. This is the mini matrix object. This is the mini matrix object. This is not the matrix. All right, the mat, that's what that is. Ooh. This is where the memory is, right? This is the pointer. So no, it's not gonna just store the 0, 0. But what is this? This is a high level thought here, guys. What is that? What is this thing that I'm highlighting? What am I highlighting here? What is that? What is that? Someone tell me, what is that? I'm basically saying mini matrix equals mini matrix here. What is that? That's this. So you know what this does. We're going to pause on this. You guys have to follow me with this one. This here, what I've highlighted, calls this function. Not function, but operator. Does it make sense? This, what I've highlighted, calls this. Why? Because I said mini matrix equals mini matrix. Calls the assignment operator. This calls the assignment operator. This calls the assignment operator. Why? Because we're dereferencing. This is a pointer to the object that this, say, function was called from, right? If we dereference this pointer, we get an object. What is the type of that object? Well, it's a mini-matrix object. So then what does the expression look like? Mini-matrix equals mini-matrix. Is there some operator that has those operands? Yes, there it is. What? There it is. The left-hand side is already alive. That's this, all right? And then the right-hand side is the copy. So guess what? Whenever you do a rule of 3, don't worry about deallocating, reallocating, all this stuff. Just initialize your parameter, or not your parameter, your member. Initialize your member, and then call the assignment operator. I'm helping you out for assignment 6. When I make you do this, just type that, all right? Initialize and type that. That's all. That's all you have to do. But this is dependent on the implementation of the assignment operator being correct. So let's make a correct assignment operator. Okay? Let's make a correct assignment operator. So the first thing we're going to need to do is make a deep copy, right? Now, obviously, this is a mini matrix which has a constant height and width. So chances are we don't have to do a deallocate, reallocate. But in your assignment, you will. So I'm going to go ahead and do that for you. So here's what I'm going to do. I'm going to say, hey, if this matrix does not equal null pointer, if this matrix does not equal null pointer, I'm going to just delete that stuff. Wow, look at me. I copy-pasted everything. I'm just going to delete it all. Okay? So step 1 is deallocate. Deallocate old matrix. We don't need it anymore. It's probably the wrong size, okay? In your assignment, it's probably the wrong size, so you have to deallocate it. Next, we got to reallocate for a deep copy. Okay? Allocate for a deep copy. Let's do that. Well, I'm just going to go up here and do this. All right, be sure to overwrite the width and the height here. I'm kind of making some... I made these constant, but I kind of want to mimic your assignment here. So let's pretend like we're doing your assignment. Let's make sure that we get this height equals the copy's height. Let's make sure that this width equals the copy's width. Okay. That should be okay. And then we'll reallocate, right? And then we'll make a deep copy. Well, we can just do that here, can't we? Copy.mat I j. Okay. Now, I kind of sped through that. I know some of you are probably a little bit lost here. And that's fine. I would recommend watching this video again. We kind of went over this previously, all right? I'm just kind of piecing together what we've already done. Of course, I have a lot of practice with it, so I'm able to just kind of copy-paste some stuff. But what did I do? I'm basically saying, say, I don't know, mm3 is equal to, I don't know, mm2. Let's pretend that these are not the same dimensions. They're not the same dimensions. And so whatever dimension mm3 is not good enough for mm1. So the first thing we have to do is delete mm3's old matrix. Next thing we need to do, copy the dimensions of the new matrix. Then we have to allocate memory for those dimensions. And then we have to make a deep copy of that matrix. So guess what? Every time I call the copy constructor, I will be calling the assignment operator. And this will probably handle it all. Are we lost? I imagine we probably are a little bit. But for the most part, you understand what I did there, right? I didn't speak gibberish. You kind of have an idea of what's going on here. That's the most important thing. You have an idea of what's going on here. If you don't, let me know. But Yeah. Okay, so make sure you come back and watch this video. Now we're going to move on to, we've only got 15 minutes left, so we have to talk about some other operators, okay? We have to talk about some other operators. Now, up until this point, I've given you an example of one that has to be a member of the class. That is your equal operator. Yeah, I understand. That happens. I've given you an example of an operator that's a member of the class. That's the assignment operator. I've given you an example of an operator that can be a part of the class, but it can also be outside of the class. And now I need to give you the example of these O stream and I streams, okay? If we have time, we'll get to this bracket one. It's really simple, though. So let's get started, okay? Let's get started here. Recall, these have to be global operators, all right? These have to be global operators. So if they're global, chances are we're going to supply both parameters. Now this one is pretty simple. All right, I'm just going to print it out in like a matrix form. All right, what does that look like? Well, for an I is equal to 0, I is less than m dot width. We want it to be in the correct, I don't know. I want it to be in the correct format here, so we might be going backwards, but we'll see. M dot width, right? We have to print everything on the row. Now, are we doing C out or are we doing out? Well, we're doing out here. That is the stream. And then we're going to take m.mat, say we're going to be printing each element as it goes over. So this is going to be J and I. Okay. And then I'm going to check to see if J is equal to the width minus, hold on. Width minus 1. Rather, if it's less than, then we'll print a comma. All right. You're just going to have to trust me on this one. All right. I'm just making it format all nicely. Okay. Now, all this is print, right? I'm going to print each element row by row. And then if it's not, if it's not the last element, then we'll put a comma in between them. That's all that is. Now, it's mad at me, right? Because it's private. This is going to print, like, Chef, this is just going to make a, it's going to print 3, 4, 5, and then it's going to check to see if that is the last element, right? If J is, say, equal to the width minus 1, then it will not put the comma here. So instead of looking kind of goofy, where everything is like separated by a comma. I mean, I would really like to explain this, but we are kind of running out of time here, so I would like you to convince yourself on that. Uchu says, why is it J, I? Well, that bothers you. Let's always make sure the J is to the height. Let's always make sure the I is to the width. And then we'll make it IJ. Now I'm going to ask you, this whole thing is mad at me here, right? Why is it mad at me? Because those things are private. So what do I have to do? What do I have to do? I bet if I add the comments, there, it probably makes it a little more readable. Right? It needs to be a friend, right? It needs to be a friend. So let's go make it a friend. I think it's already up here, but whatever. put it there. You're now my friend. Easy enough, right? Now, when we're ready to, we can say, hey, cout mm. Sorry. That works now. Does that make sense? This works now. Because this is a global operator here. It makes sense. Now let's quickly do the other one. All right, the other one looks like this. Now, look at this here. Do you see that this returns out? It's returning this thing. Why is that? What if I say cout string, I don't know, 3, mm2, patty, end line. This goes back to what I was talking about last time. We evaluate this from left to right. So what's the first thing that happens is that. So this will print the matrix, and then what does it return? It returns the O stream. So what does this return? This returns cout. And then it prints 3. And then what does this do? It returns cout. And then this prints the next matrix. What does this return? Cout. And then it prints patty. What does this return? Cout. Have I made my point? What does this return? Cout. But now it doesn't do anything. Does it make sense why this needs to return the stream? If it doesn't return the stream, then you can't do something like this. Cout mm1, mm2. If you don't return out, you cannot kind of combine them. Instead, you have to make them separate. If you don't return the stream, they have to be separate. But if you do return the stream, you can kind of combine them, right? Because that becomes cout. Does it make sense? Hopefully. Hopefully it does. This one will be really easy. All right, this is just the opposite. It's going to be, oh, sorry. This is just the opposite. It's an I stream. It goes in. The type is an I stream. And this is probably going to be by reference because we're going to want to put something into that matrix. So let's do it. I stream. Operator, well, this is the extraction operator. What does it take? It takes an I stream, which is the left-hand side or in, and then some matrix here on this side. Okay. And so then let's do for each. This depends on if you want to input them kind of column by column or row by row. Does that make sense? In this case, we're going to do row by row. So we're going to go 1, 2, 3, move to the next row. 4, 5, 6, move to the next row. 7, 8, 9. So this one's really simple. We say in to the matrix. We don't need to print anything here. We return in. We're just going to read in each element one by one. So what do you say we test our code, okay? Now we kind of went a little fast there, but we've got some stuff going on. So let's do things one by one. What do you say we start with a few matrices and let's see in mm1. And then let's see in mn2. Oh no. Are we dying? Are we dead? No. I think we're okay. It's just like not reading my stuff here. See ya. Why are the O and P, why are the O and P things so close together? I'm always making typos, guys. All right, so let's try it. Let me go find G++ here. This is going to be matrix 2x2.cpp. Everything compiled. Why? Because I'm a wizard. All right, let's run it. ./a.out. What is it doing right now? It's waiting for me to input these values, right? So 3, 4, 5, 6, and now it's waiting for me to input the next values, right? 1, 1, 1, 1. Now we're done. So let's make sure that those things work. What do you say? So let's see out mm1. Let's actually put it here. And then let's see out mm2. Okay, 1, 2, 3, 4. And it seems I made a huge mistake here. And then 4, 5, 6, 7. It looks like these matrices are a little goofy. It looks like I've messed this up here. You guys are probably watching me like, what the heck is this guy doing? J, I see. There we go. So that'll fix that, okay? It's 3-4, guys. It's 3-4. So now we can do some more stuff, right? Well, let's take, I don't know, let's say mini matrix mm3 is equal to mm2 minus mm1. And then let's see out mm3. Now what does this do? This calls the copy constructor, which then calls the assignment operator. This calls the subtraction operator. Let's give it a shot. One, 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 one. There we go. That's a nice matrix there. You see it? And then we're going to do 3, 4, 5, 6. There's a nice matrix. And then we're going to take 3 minus 1, which is 2. 4 minus 1, which is 3. 5 minus 1, which is 4. 6 minus 1, which is 5. Is this kind of cool? I think it's kind of cool. And then if you wanted to try another one, you could say mini matrix mm4 is equal to mm3 plus mm1, something like that. Okay, and then you can print it. And we can val grind it just to make sure that everything is working as expected, because we want that to happen. All right, looks like we got some matrices here. That looks all correct, and we have no problems. Math. All right, guys. So, truth is, I did get a little caught up today. So here's what's going to happen. We covered everything that we need to except for two little things. One is the plus plus and the minus minus. You guys have seen these before, plus plus. You've also seen plus plus mm1. I need to talk about these operators. So what's going to happen is today I'm going to release the assignment when I can. Might come out tomorrow. I'm also going to release a video with that assignment. The assignment is very straightforward, okay? It still entails some work, but it's going to be kind of condensed in that there's not a whole lot of stuff you need to read. Now, in that video, I'm going to cover this stuff, okay? It'll only take me 5 minutes, but I'll cover those pluses in the video. I'll also include them in the notes and in the assignment PDF, okay? So you'll have 3 places that you can go to learn about those. Obviously, I probably would have covered them if we didn't run out of connection on Tuesday. So just make sure you watch that video, okay? Check out the assignment. I'm going to tell you how to do these ones. And you should be completely good to go for everything, okay? I've given you examples for all this stuff, all right? You guys make me so happy when you say stuff like that. So thank you so much for coming today. I hope you learned something. I hope you guys have a great weekend and a great rest of your day. You're always welcome to message me if you need, and I will see you guys on Tuesday, okay? I will see you guys on Tuesday. Thanks for coming today, guys, and I'll see you guys later. Young, you are welcome. CS202 student, you are welcome. Cade, you're welcome. Siptos, you're welcome. Top Wolf, you are welcome. Have a great day yourself. Kane, you are welcome. Uchu, gonna need a review, that's for sure, but you're welcome. Fuzzy, happy Friday's Eve. Make sure to hydrate, I will. Hamma, have a great day. Nick, have a great day. Chef, you are welcome. Have a great weekend. Giovanni, have a great weekend. Good to see you. YCS, you are welcome. Turbo, peace out to you too. Nick said, have a good weekend, everyone, for sure. Pig, you are welcome. Have a great weekend, guys.